So let's start with are we abstracting too much? So my name is Mauricio Eduardo Chico Pochabo. I am a Ruby programmer since Ruby 1.8.6. So yeah, it was a little while ago. Rails was a little bit different. And right now I am working with functional programming languages. This talk will also be a little bit about how the functional programming language teach me a little bit about this de-abstraction. So I am not abstracting more, I am abstracting less. That's one thing that we're going to show right now. So what exactly do we expect on this talk? So I'll first show how we do things today. So what are the abstraction problems that we do today, and how we are trying to solve them with DSLs, domain-specific languages. For example, I'm going to show dry schema a little bit. And in my opinion, the problems that we have with domain-specific languages. And then we're gonna throw it all away and see if we can make a better code and what can we do with this, like better code, better, or let's say less abstraction, and how do we integrate over plain data. So let's start with simple RESTful API. I'm using JSON here, but we could use whatever, like forms, form field, form for in Rails, whatever. It doesn't matter too much. So the first thing that we're going to do is to validate, and then we're going to save. And in this case, I am imagine that we're going to save in a SQL database. I'm giving the example of Postgre, but it could be MySQL or whatever. And what we do today is we accept input, validate the data, and save. And what does each one of these things mean? So accepting input in Rails is this params field. So params, it's like an abstraction over JSON. So when we get a JSON payload, what we are going to do is abstract it into a map, and we are telling that person is required, and we permit the name and age inside the person. So imagining here a simple JSON object. And validation is validating presence of name and numericality of age. This is quite interesting because validates numericality means that age can be a string. And if it is a string, it will try to validate if it's a number. But will not convert for you. So when we save data, in this case, when Active Record or the SQL object relational mapper saves the data, it will convert age to a number. So we have 3 steps that deal with the same kind of object, that's the JSON. And also, there's another little bit problem here. This is what we call a closed schema. A closed schema is, I do have an object, but they are closed, like only these specific fields are accepted. And if we get anything that's more than what we are expecting, they will be removed. And here it's what we call an open schema. It means that we validate the presence of name and numericality of age, but if anything else comes in, it will also be accepted. That's not exactly what we want most of the time, because we are having trouble here with doing the same thing twice in different places, and we can have abstraction problems with it. So one thing to solve that is with dry schema, for example. Dry schema is a library that will pick up our data and validate, coerce, convert, and accept in the same place. So I'm telling here that name is required and must be a string. Metadata is required and must be a time. And here's what it shines, because JSON doesn't have the time data type. So if you will come as a string, the time will come as a string. And what try schema will do is try to convert that schema, that string, to time. And if it's able to convert, then it validates. And also, if it can't convert, it will not blow up an exception. It will simply say, okay, so Mary-dat is not a time. So it's a validation error, not an exception. And age is optional, so age can be present or not. If it's present, it can be null because of the maybe. And if it's not null, then it must be an integer. And the same rule apply here. Like if we are receiving the age as a string, it will try to convert that to integer and then blow up a validation error if it's not a valid integer. So again, it's a beautiful library to work with that. And for very simple cases, very simple situations, dry schema is enough. But let's suppose we have this kind of situation here right now. We have 3 different kinds of data to represent the user. And the first one, email, is mandatory. On the second one, mail is not mandatory. In fact, it can't exist. We have to remove if it exists. But permissions is mandatory. And what is really complicated here is permissions, it's inside roles. So permissions, if we want to add this validation here, we'll somehow have to merge schemas. And it's not clear if roles will be inside permissions or not. And company and from are mandatory in this third example. So yeah, it also have the same problem. We can't merge these things. So recently, dry schema did add a version that have the merge schemas. But again, maybe in the future we receive another schema that name is not present and can't be present in this case. So it's, again, not clear how we merge this. We would have to add APIs for every situation, and we can't create them programmatically because it's a DSL. Oh, we can solve this problem here with active record single table inheritance. But now we have an abstraction layer that's quite complicated. So we have a database. The database is abstracted by SQL. SQL is being abstracted by active record or any other object relational mapper, for example, SQL in Ruby or Ron or Beam. And we are using a single table to work as object-oriented classes. If you know Postgre, you know that Postgre have the concept of table inheritance, but it's different than what object-oriented programming is. And the question is, we are doing all of this just to validate an input. And what if I don't want to save it into a database? And this is quite interesting because I had this problem when I worked with a company. So people were creating tables so that they could use single table inheritance, but they only wanted to validate inputs. So this table had the field necessary for single table inheritance just to validate inputs. It wasn't really necessary in the production code. We also have a problem if I don't want to use SQL. And the most problematic, in my opinion, is how do I detect that code right now? So we have code that can be dead, like I'm not using it anymore, but it's also present in the database. So I have to query all my clients to check if that field exists, and if that field contains the string, that's the class name, just so I can detect that code and remove it. And if I want to remove single table inheritance, I have to do a really complicated migration. So it's not really that good to be so abstract in this moment. So what can we use? Let's try to remove this idea of DSLs. Like, this don't work. because it's global and have other problems. Let's do pure objects in this case. So validator is a new object. I am adding the base validations here. Exactly the same as dry schema, except it's a different API. And we are kind of doing a builder pattern, like adding validations as it go. And derive could be a deep clone. So it's cloning the base validator, and it's deep. So if I get roles, I am not getting the same roles that this base validator have. It's a copy, and I can add validations to this derive. So it's way easier to define, to get and add new validations on this kind of code. And also it's way easier to delete a validation. But okay, we already dropped a level of abstraction. Let's drop one more. So we know the shape of our data, right? This is the shape of our data. We have keys, we have values, and a schema is mostly the same keys, but different values, or in this case, different types. So we could, for example, replace the values with a way to define which they are. So in this case, name is a type string, roles is not required. So it's way easier, and we gain some interesting and clever tricks that we can do this. First is that we don't have to add APIs to merge. Every API that works with HashMaps and arrays will work. And if it's becoming complicated to merge different HashMaps to generate new schemas, we can add an API to merge HashMaps, and then it will also work not only by two schemas, but also for any specific HashMap. So this is quite neat. For example, we could have the same API to work with the schema and to work with the data. So we can merge schemas, we can merge data. With the same API, we only write once, and we gain lots of benefits. And also, it's easier to inspect information. And this one here is kind of a big deal, and I'm going to show why. So to do that, I'm going to imagine how these ideas can be if they were implemented in Ruby. So I'm going to blow up a little bit and expand a little bit these ideas to define new libraries and other things. They don't exist in Ruby yet, but maybe one day. So the first thing is we have the schema. With the schema, we can derive, let's say, an array. And this array contains the first element is, for example, div, and the second element of the array is another array containing the first element input. So if it's not clear, this is HTML. So input type text, name, it's missing a dot here, but anyway, username. So name comes from the field name, so works. And the input type text comes from the type of schema that we are deriving. So imagine how wonderful this could be. Like you define your schema and you have a form for free with every field and every value and every, let's say, possible type already for free. And if you don't like this specific form, you can, I don't know, add a new field before this div here. And now we have a label, or you have a separator, or maybe a header. It doesn't matter. It's just what matters is that it's easier to insert new HTML in the middle of this element than, I don't know, to work with them DSL, for example, with form for or form fields. And it doesn't work only with HTML, but also with SQL. So users.id and users.name. I am doing here a little bit of a stretch. So the double underscore will be the dot. So users.id, users.name are the select clause from the SQL. And from users and where it's like this format. And if it's not clear, it's easier to compose this than it's to compose, for example, active record queries. For example, suppose I want to negate this query. If this would be like a SQL object, a row RB object, or an active record object, it's not that clear how do you get everywhere and then negate everything. You could use RL, but RL API is not stable over versions. And so how do we negate this query? And it's simple. You just change the where to start with not in the original query, and it's negated. So you know how to do that. And if you don't know, it's easy to derive a way to do that. You don't even have an API, like it's pure HashMap manipulation. And also, it's easier to compose pure data. So supposing we could like have the has many belongs to and everything already defined for us. Let's suppose we already have this. If we are using Rails, we probably have. And I want to query for user's name and roles dot name. This query will never work, obviously, because user's name and roles name are in different tables. But we could generate from this element this query by looking at roles and seeing that if I want to merge a path that I have from users to roles, is through this join. So it will generate a join for us. And yeah, it's possible. The other things are just copied, like select is copied, where is copied. So if any new table happens in the where or in the select or in the having clause, we can just auto join them and everything will be fine, everything will work. Okay, if I'm not convinced, if I didn't convince you yet, let's do something even more mind-blowing. So suppose we have a system and we need to calculate how much money the user have in his accounts. So we have a table called people when we have all the users that use our system. We have a table called accounts that depends on the user. And when the user deposits something on the account, or when it withdraws something or make a purchase, it will generate what we call a line item. So the line item is, at this point in time, this account deposited, let's say, some amount or withdraw some amount. And periodically, maybe after 100 line items, maybe once per day, we will generate the snapshot. So it's the sum of every line item that will generate like a specific point in time when it says that, okay, the amount that we had in this account in this moment was this one. Okay, so far so good. If I want to know how much money a user have, it's really easy. I just query snapshots, and then I query, I query the last snapshot, and I query every line item that happened after that snapshot and sum everything. So suppose I get like, okay, so the user had 100 yesterday. So I query 3 line items and see that he made 3 purchases of 10 money, whatever. Then I know that by summing everything, I will get like 100 plus minus 10, minus 10, minus 10, 70, and that's okay, it works. Okay, so now our company grew, everyone was really happy, and B Corp Incorporated came and purchased our system. And they decided that, okay, your database of people, accounts, and snapshots is fine. We are going to migrate everything to your database, so we don't have to worry about using 2 different databases. But your line items is still not complete. We do have our own line items because B Corp accept, let's say, purchase with credit and debit cards. And when you purchase something with cards, the transaction will stay in a pending state, and we will receive in the end of the day, in the end of like 3 days, or I don't know how many days, an FTP file containing the transactions that indeed were confirmed by the operator, by MasterCard, by Visa, or whatever. So that's what happens. If I once you query things right now, things became more complicated. First, because B Corp line items, it's in different database, maybe different technology, and FTP files are not active record objects, obviously. So we have to read these FTP files, and we don't want to waste time like reading everything. So how do we resolve things? How do we solve this problem? And the key word here is resolve. I'm going to generate some soft dependencies on these elements. So snapshots, line items, sorry, depends on snapshots, and B Corp line items depend on snapshots. And the sum of pending elements, it will depend on snapshots, line items, and the B Corp line items. This is only depending. I am not considering FTP files. To consider FTP files, I'm going to create a sum confirmed. We'll generate the same dependencies here, and also the FTP file. So sum confirmed will query the same data, and then query also the FTP files, and obviously we have a total. That's the confirmation of both. So imagine an API that will work like that. If we would abstract with object-oriented classes and other things, we would probably have to do these integrations manually. And that's not fun. I did this a lot in the past, and then you discover that you needed data from here, and then you kind of keep moving objects around, and you have to filter manually which one is used in each place. So, okay, the keyword is this API called the resolver. So the resolver is simply something that accepts a bunch of inputs, in this case, the person ID. Again, I'm using the double underscore here as a convention. That's the ID of the person. And the output is this nested element. So it's a map, which the first, with only one key, that's accounts. And the accounts, it's an array containing account IDs. And this is a batch resolver. Batch resolver means that I'm going to receive multiple people, and then I have to return multiple accounts, one for each person, sorry. And so the inputs.map, it's here because I have to return the accounts in the same order as the person came. So if I receive so I am querying the inputs, getting the person ID, and then returning the accounts of that person. So supposing I have this kind of input, like person ID 1 and person ID 20, I will have to return two elements containing the map of accounts. So here's the first one. The person ID 1 only have a single account ID that's called 121, and the person 20 have two accounts. One is called 919 and 2030. And as you can see, it's a single map containing both accounts. So first element from the person ID 1, second element for the person ID 20. Where this library could shine is we receive an input that contains the account ID and the generated data of the snapshot. So I don't have to depend on a single input. I can depend on multiple inputs. And this library will make the graph for me. I don't have to manually solve the dependencies. And the outputs are going to be the line items, the time that line item happened, and the amount with you, not without you here, of that line item. And again, it's a batch resolver. So what will happen here in the inputs? I will have to construct a single query that will query every line item that I want. So it's a where clause that will filter only line items from that account that occurred after the snapshot was generated. This could be complicated if we are using the traditional ways. But let's suppose we have in our hands the API that I showed earlier with the queries model as a map. It's as simple as doing something like this. The first element is an OR, and the second element is the inputs. I'm going to compose the inputs with AND. So account ID equals the account ID that I'm expecting. The line items time, it's greater than the time that snapshot was generated. This is AND, so both conditions must match. And in the beginning, there's an OR. So it means that the query will be account ID equals, I don't know, 101, and line items time greater than something, or account ID greater equals other thing, and line items time greater than other thing. So it will construct the query for us. It will be a big query, but it doesn't matter. We are not writing the big query. We are abstracting it by not abstracting it. It's weird. Okay, so where it really shines is that, again, it's not global. I can get the resolvers locally. So I generate an array of my resolvers, and I'm going to define this query language here. That's an entity query language. It's not exactly what it stands for, but anyway, it works for us. And I'm going to build this entity query language, and I'm going to call it with the entities that I want and the query that I want to solve. So the API is simple. I can only pass a single element, and then I am going to query for the data, or I can pass two elements, and the first one will be the first entity. So the first entity will basically be the person ID 1 and person ID 20, and the query that I want is, I want the account ID and the sum of pending elements. What this will do is will issue 4 and only 4 optimized queries for my database, or in this case for both databases. One for accounts, one for snapshots, one for line items. This query is optimized. It's exactly the one that we saw in the earlier slide. And another for the B Corp line items, also optimized. The B Corp line items probably would be exactly the same query, except that we will have to get some correlation ID or the status of the line item. And the second query that I'm doing here, I am summing the total, so I don't want only pending. So this will also issue 4 optimized queries and will only search relevant FTP files. And we're going to see how the machinery can know which are relevant and which are not. But we can do it more. We can, if you saw on the last slide, if I do the query both times, it will issue 4 queries and issue the same 4 queries again. We can do an entity cache. An entity cache is basically a cache. So if I do 4 times the same query, it will not issue the same 4 queries 4 times. It will just issue once, and then it's cached. It will keep doing, it will just hit in the cache and not like using the database or other things. The interesting part of this entity cache is if we had joint accounts, for example, 2 people or 3 people can have the same accounts number. If we keep querying for the sum total, when it detects that the account already exists in the cache, it will not issue the other queries and not query the FTP files. It will just use what is in cache. So for joint accounts, we are going to issue exactly 1 query. That's just to get the account. Or we can even query with a more complicated query. This query language is quite bizarre for people that are not used to, so I'm not going to explain a little bit, but what I'm doing here is I'm asking for the person ID 1, the total, and the person ID 7, the pending. And this will only read FTP files from the person 1. Okay, how exactly this work? So the idea is the library will do a graph of dependencies. And with this graph, given the query, it will try to search for the last resolver that will resolve our query. In this case, is this one. So it will pause the other resolvers and backtrack until it finds a resolver that it can be run. In this case, only the first ones, because they are the only ones that accept the input A, and I only have the input A. So it will start from here. And for A equals 1, suppose the result is Z2. It can't call this resolver yet, because this resolver depends on both data. So it will have to call this second resolver and this third resolver. Okay, it could call this resolver, but I am supposing that these resolvers here that have different colors are batch resolvers. And the idea is, if the resolver is a batch, it will not run after, it will only run, after other resolvers have run for the input that I have. So in this case, I have A equals 2. So I'm going to do the same queries here, and I get Z3 and B2. And that's where things become interesting, because even without entity caching, if I am doing the same query, B equals 2 already exists in my machine. So it will not query this one again. It will just reuse the data. So now I have Z and C and Z and C for both inputs. And now I can call the batch resolver. And again, I have to return the same order that I called. So D equals 1 is equivalent to this first element. And this first element is equivalent to the A equals 1. And it will call the next resolver again. So D1, D3. These ones are easy. And again, this one is also a batch resolver. The same rules apply. So it will first call this one and then call the second one. It can't call this before call this, because this one depends on both. Okay, so for E99, suppose I have F88, and for E31, suppose I have F101. Okay, I only want H for A equals 1. I don't want H for A equals 2. So the machinery knows that A equals 1 generated this kinds of inputs, or of outputs. So A equals 1 generated B2, Z2, and so on and so forth. So it will call the resolver with only this data here, E99, but as it's a batch resolver, it will wrap into an array. So now I have ZG0, and now I can call what's missing. And in this case, G0 and F88. So this is the last return. So in the end, the result for A is 8088, and the result for the second one is 101. So imagine how wonderful it is to work with this. Like, we are doing some heavy, complicated code, and we just have to matter the data that we receive. We don't have to filter anything. It's already filtered for us. We can also forget about trying to imagine which data depends on which, because the library does that for us. Okay, so is this even possible? Like, I am imagining things here, and maybe I'm become crazy or something. And every library, every code example that I showed here exists in another language. So in this case, for this data, this schemas are data, there's prismatic schema and Mali. For the HTML over data, there's the hiccup data and Regent. Regent is really interesting because it's working on React. So imagine, if you can, imagine how wonderful it is. You have a JSON, you make a function that transforms this JSON into a data structure, and the page will automatically refresh only the elements that you need, React style. So SQL over data is called Honey SQL, and the idea of auto-resolve with the joins and so on, it's an experiment that I'm doing right now. It works for some cases. It's not battle tested yet, but it works for multiple cases that I tested. That's called B record. Any influence from active record and Honey is not coincidence. And this library of resolvers, it's even more amazing that I showed here. It's called Python. It's, I believe, the most interesting and maybe the most powerful way of organizing code that I ever worked with. In fact, I did use Python for complicated things and for simple things, and it shines in both cases. And the new version of Python, it's Python 3, also contains the support for, let's say, prioritization. So you have resolvers that return the same data. You can define if one is more prioritized than other, and it's dynamic, so you can like prioritize with a function. And also one of the things that it also shines is that you can have optional fields, optional inputs. So if the input is present, it will be used, otherwise it will not. And if you like Python and like HTML over data, you can join both together with Fulcro. So we'll make a query in Python, and you'll define HTML structure with arrays and maps, and this will become HTML for you, and automatically refresh only the fields that you need with React. So yeah, it's amazing. Okay, so the question that I think we can imagine is, can we have this in Ruby? And the answer is yes, we can. Every one of these slides is doable in Ruby. In fact, I try to parse everything in the Ruby repo to see if they are doable, and they are really doable. And the answer is we will have it in Ruby. And well, we kind of already have. If you are using JRuby, you can reuse most of these libraries because they are for Clojure, and Clojure do have like it runs on the JVM. And if you want to use, for example, Regent, you can also use with, let's say, GraalVM. But that's not what I mean, right? I mean, can we have a pure Ruby implementation of these libraries? We will have it in Ruby. And the answer is probably not. And it's kind of sad to answer that. And why? It's all doable, it's all possible. But the first thing that I can imagine a person will ask when we show this kind of data for this kind of libraries for them is, how do I integrate it with Rails? And the answer is, you don't. I mean, that's kind of the point, not abstract things. And Rails do abstract everything for you. So yeah, unless we can somehow free ourselves of this idea of the Rails way for some applications and start thinking about, okay, so how do I solve this problem and not go to the terminal and do Rails new and do whatever we want, we probably will not have these kinds of tools. And there's also another thing that I want to share is that the myth of optimized for programmer happiness. So yeah, we can have a language that's optimized for programming happiness, but what exactly is happiness? Sometimes when we want to be happy, when we are through a hard time, for example, we can spend our money on our party, and then we can't pay the rent. So working with this kind of abstraction is kind of like, yeah, I know it's hard right now, and I know that I don't want scaffold anything. So yeah, let's simply do this. So scaffolding is most like this. Most libraries, most ideas that we use, most tutorials in Ruby is, let's scaffold everything, and then we delete most of the code and do what we want. So if we're going to delete, why are we even scaffolding? Okay, so that's it. If anyone have questions, I can answer that. I can answer in Portuguese and English if you want.